right, so today we're going to talk about isotopes. So, what exactly are isotopes? They are atoms of the same element, but they have a different mass. Okay, so what does that mean if they're the same element? So if it's atoms of the same element, this means that they're going to have the same number of protons, but a different number of neutrons. Because remember, our protons and neutrons make up our mass. Okay, or we could say it differently because we know that also proton number gives us our what?
Atomic number?
Atomic number. So we've got the same atomic number, but a different... Okay, if we have a different number of neutrons, that's going to change our... Mass. Okay, a different mass number. So that could actually be expressed literally same sentence, just using two different forms of vocabulary to describe it. Okay, so an example of what that might be would be, we've got sodium with a mass of 23, and remember its atomic number is 11. We can find that off the periodic table. And we have another sodium, and he's got an atomic number of 11. That's never going to change. If you change the number of protons, you change who that element is.
It would no longer be sodium.
Correct. And he's got a mass of 24. So if we were to take our mass number and subtract it from our atomic number, how many neutrons would sodium 23 have? 12. Okay, and if I come over here and I subtract my mass minus my atomic, how many neutrons would sodium 24 have? 13. So the only difference between these, you notice they have the same atomic number, but they have different mass numbers.
Okay? And therefore different neutrons.
Therefore different number of neutrons.
Got it.
You're so smart.
I know.
All right, so... when you look at the mass numbers from what we've seen so far, you've seen whole numbers, right?
Yes.
Okay. But when you look on the periodic table, do you see whole numbers for the mass number?
I see a whole bunch of decimals.
Whole bunch of decimals. And if you see right there, she's correct. All of those numbers have decimals behind them. And if you want to remember that your bottom number is the one that is your mass number.
Big number, mass number.
Big number, mass number. Okay, so what we're going to talk about today is why is there a decimal on the periodic table, but from everything we've seen so far, no decimal?
Good question.
Averages. Do those have decimals in them?
I guess it depends on what you're averaging.
Yeah, true. So we're going to take the average mass of isotopes today because obviously there can be different forms of each type of atom because we have isotopes. So, we're going to talk about the average atomic mass. Now, average atomic mass it's a special kind of average. We actually call this a weighted average, meaning that each number that you average holds a little bit different weight. Usually you think of if you have three numbers and you take the average, you're just going to divide by 3. Not quite that simple.
It's kind of like averaging your GPA.
Yes, it is. For those of you who have classes that have a little bit more pull than others, let's say you're
like an AP class or a PAP class.
Exactly. So we have a weighted average of our mass numbers of the isotope of an element. Okay, so we need to get that down. Now, the crazy thing is that scientists today actually have a tool that they can sort elements or molecules out by their mass. I bet she used one in college.
Totally didn't.
What? Well,
I bet Kim did.
Miss Copeland did. It's called a mass spectrometer, and I got to use one too.
Oh, I probably did.
Okay.
I don't remember.
She doesn't remember. She's slept since then. All right. So one of the things that you want to remember, so we have an average, and we've got carbon is probably one of the most common isotopes that you'll hear or talk about in general. So I've got a carbon 12, a carbon 13, and a carbon 14. Remember that those numbers that I wrote behind each of them are their mass numbers.
Mass numbers.
Okay. Now, the average atomic mass for carbon, which you'll find off the periodic table, is 12.011.
Pretty darn close to 12.
So, if it's really close to 12, what do you think most of that average is made up of?
Probably gonna be 12.
Carbon 12. Exactly. All right. So, we want to actually have an equation because we don't have a mass spectrometer to filter out this kind of stuff. And our equation for our average atomic mass is going to be equal to the sum of each isotope mass, sorry about that, guys, times your percent abundance. Okay. Now, can you use decimals in math?
Totally.
Decimals. But can you use percents in math?
If I make them decimals.
If you make them decimals. You remember how to make a percent a decimal?
Well, yeah.
Okay.
You take your percent and you divide it by 100.
Is there something easier than that I can remember? I'm not good at math.
Well, let's see. Every time I divide by 100, my decimal place is going to move over twice to the left.
Left. All right. So if we want to change our percent to a decimal, we are going to change or move our decimal
Two times.
to the left.
Two times to the left.
You're going to use this all the time. Later on in chemistry, next semester too.
Totally.
All right, so time to do some practice problems. You want to stop it?